Welcome! I am Teacher M. This tutorial video is focused on finding the derivative of a rational function using definition of derivative. If you're interested, stay and watch the entire video. To begin, find the derivative of f of x is equal to 1 over x. F prime of x is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. Find f of x and f of x plus delta x separately. F of x is the function, which is 1 over x. And f of x plus delta x is equal to 1 over x plus delta x. Substitute those to the derivative definition. Limit of f of x plus delta x, which is 1 over x plus delta x, minus f of x, which is 1 over x, all over delta x as delta x approaches 0. At this point, you have freedom on how you will simplify this complex fraction. Usual process is to simplify the numerator, then divide the result by the denominator. In this video tutorial, we will attack the complex fraction in a slightly different way. To simplify this, get the LCD of all terms in numerator and denominator. In numerator, the LCD are x plus delta x and x in denominator is 1. Since when any number multiplied to 1 is still the number itself, we can now not to write 1 in the LCD. Multiply the LCD to numerator and denominator. Multiply first term of the numerator to the LCD. X plus delta x is eliminated. The remaining factor is x. Multiply this to the numerator of the first term, which is the product is x. Next, multiply the second term of the denominator to LCD. Factor of x is eliminated. The remaining factor is x plus delta x. The product of the remaining factor, which is x plus delta x, multiplied to the denominator of the second term, which is 1, is x plus delta x. Get the product of the denominator and the LCD. Remove grouping symbols in numerator. Limit of x minus x minus delta x all over the whole denominator as delta x approaches 0. Combine similar terms in numerator. X minus x is 0. Limit of the remaining term in numerator, which is negative delta x over the entire denominator. Simplify it further. Delta x in numerator and denominator will be eliminated. And it is equal to the limit of negative 1 over the product of x plus delta x and x as x approaches 0. Apply limit property. Limit of negative 1 as delta x approaches 0 over the limit of the denominator as delta x approaches 0. Rewrite the numerator and apply limit properties in denominator. Limit of x plus delta x as x approaches 0 multiply to the limit of x as delta x approaches 0. Rewrite numerator and apply limit properties in the first factor of the denominator, which is x plus delta x. It is equal to limit of x as delta x approaches 0 plus limit of delta x as delta x approaches 0 multiplied to the second factor of the denominator, which is limit of x as delta x approaches 0. Get the limit, and it is equal to negative 1 over x plus 0 multiplied to x. Simplify, we have negative 1 over the product of x and x. Get the product in the denominator. Thus, the derivative is negative 1 over x squared. The derivative of f of x represents slope of the function at every point on it. Example, find the slope of the function at x is equal to negative 1/3. Before proceed in solving the slope of the function, let's make it clear the output of a function and output of a derivative. Function is a system of input and output. Input is the x-coordinate or domain, and the output when you substitute the x-coordinate to the function is the y-coordinate or range. Derivative of function is also a function that has input and output. Input is x-coordinate or our domain, and the output is the slope of the function. Thus, the original function gives you the y-coordinate while the derivative gives you the slope of the function. To visualize it, this is the point where we want to find the slope of a curve. To solve the slope of the function at x is equal to negative 1/3, use the derivative. Substitute x-coordinate. We have f prime of negative 1/3 is equal to negative 1 over the square of negative 1/3. Simplify the denominator. It's equal to negative 1 over 1 over 9. Simplify. The slope of the function at x is equal to negative 1/3 is negative 9. To visualize how steep the curve at x is equal to negative 1/3, find the equation of the tangent line on the curve at x is equal to negative 1/3. To find the equation of the tangent line, use point slope form. In this example, x-coordinate and slope are known. To complete the values needed in point slope form, solve the y-coordinate. To find the y-coordinate, use the function. Substitute x-coordinate. f of negative 1/3 is equal to 1 over negative 1/3. Simplify. The y-coordinate is negative 3. Substitute all values on point slope form. Y minus y-coordinate, which is negative 3, is equal to the slope, which is negative 9, multiplied to x minus x-coordinate, which is negative 1/3. Simplify. We have y plus 3 is equal to negative 9 multiplied to x plus 1/3. Distribute negative 9 to each term of x plus 1/3. Then, y plus 3 is equal to negative 9 minus 3. Subtract 3 to both sides of the equation. And y is equal to negative 9x minus 6. This is now the tangent line on the curve at x is equal to negative 1/3. On the graph, this is the tangent line on the specific point on the function. Another example. What is the derivative of h of x is equal to 2x over x minus 1? H prime of x is equal to h of x plus delta x minus h of x over delta x as delta x approaches 0. Find h of x plus delta x and h of x. Continue. H of x is 2x over x minus 1. H of x plus delta x is 2 multiplied to x plus delta x over x plus delta x minus 1. In numerator, distribute 2 to each term of x and delta x, and in denominator, remove grouping symbols. We have 2x plus 2 delta x over x plus delta x minus 1. Substitute h of x and h of x plus delta x to the definition of derivative. And it's equal to the limit of h of x plus delta x, which is 2x plus 2 delta x over x plus delta x minus 1 minus h of x, which is 2x over x minus 1 all over delta x as delta x approaches 0. Find the LCD of numerator and denominator. Then, the LCD, which is x plus delta x minus 1, x minus 1, and 1. We can rewrite the LCD without the factor of 1. Multiply it to the numerator and denominator. Get the product. Multiply the LCD to the first term of numerator. The factor of x plus delta x minus 1 is eliminated, and multiply the remaining factor, which is x minus 1, to the numerator of the first term, which is 2x plus 2 delta x. Next, multiply LCD to the second term of the numerator. The factor of x minus 1 is eliminated, and multiply to the remaining factor, which is x plus delta x minus 1, to the numerator of the second term, which is 2x. In denominator, get the product of the denominator, which is delta x, and LCD. At this point, focus on numerator. Get the product of x minus 1 and 2x plus 2 delta x, which is 2x squared plus 2x delta x minus 2x and minus 2 delta x minus the product of x plus delta x minus 1 and 2x, which is 2x squared plus 2x delta x minus 2x over the entire denominator. Remove grouping symbols. We have limit of 2x squared plus 2x delta x minus 2x minus 2 delta x minus 2x squared minus 2x delta x plus 2x over whole denominator as delta x approaches 0. Combine similar terms in numerator. 2x squared minus 2x squared is 0. 2x delta x minus 2x delta x is 0. And negative 2x plus 2x is also 0. Limit of the remaining terms in the numerator, which is negative 2 delta x over the entire denominator. Simplify it further by eliminating the factor of delta x. Limit of negative 2 over the product of x plus delta x minus 1 and x minus 1. Apply limit property. Get the limit of numerator and limit of denominator. We write numerator and apply limit property in denominator. limit of x plus delta x minus 1 as delta x approaches 0, multiply to the limit of x minus 1 as x approaches 0. Rewrite numerator. Apply limit properties to factors of the denominators. Limit of x as delta x approaches 0 plus limit of delta x as delta x approaches 0 minus limit of 1 as x approaches 0 multiplied to the limit of x as delta x approaches 0 minus limit of 1 as delta x approaches 0. Get the limit? We have negative 2 over the product of x plus 0 minus 1 and x minus 1. Simplify, and it is equal to negative 2 over the product of x minus 1 and x minus 1. Rewrite the denominator. Thus, the derivative of the function is negative 2 over the square of the difference of x and 1. Using the derivative, we can now find the slope of the curve at any point on it. To illustrate it, find the slope of the function at x is equal to negative 1. To solve the slope of the function, use the derivative. Substitute x coordinate to the derivative. We have h prime of negative 1 is equal to negative 2 over the square of negative 1 minus 1. Simplify. We have negative 2 over the square of negative 2 minus 1, which is negative 2. Continue. Negative 2 over the square of negative 2, which is 4. Simplify. Thus, the slope of the function at x is equal to negative 1 is negative 1/2. Using the slope at the given point, find an equation with the tangent line on the function at the same point. Find it using point-slope form. Notice that y-coordinate is unknown. To find it, substitute x-coordinate to the function. Substitute x-coordinate to the function. H of negative 1 is equal to 2 multiplied to negative 1 over the difference of negative 1 and 1. Simplify. We have negative 2 over negative 2. Simplify. Therefore, the y-coordinate is 1. Substitute y and x coordinate and slope to the point slope form. Y minus y coordinate, which is 1, is equal to the slope, which is negative 1/2, multiply to x minus the x coordinate, which is negative 1. Simplify. Y minus 1 is equal to negative 1/2, multiply to the difference of x and negative 1, which is x plus 1. Distribute negative 1/2 to each term of x plus 1. We have y minus 1 is equal to negative 1/2 minus 1/2. Add 1 to both sides of equation. And is simplified to y is equal to negative 1/2 plus 1/2. Thus, the equation with the tangent line on the curve at x is equal to negative 1 is y is equal to negative 1/2 x plus 1/2. On the graph, this is the point we are referring to, and this is the tangent line with the equation we solved a while ago. Last example, find the derivative of g of x is equal to x squared over 1 minus 3x. I encourage you to pause this video and try to find the derivative of the function. Then check your answer later. To continue, derivative is equal to g of x plus delta x minus g of x over delta x as delta x approaches 0. G of x is x squared over 1 minus 3x, and g of x plus delta x is the square of x plus delta x over 1 minus 3 times the sum of x plus delta x. In numerator, expand the square of the sum of x and delta x. It is equal to x squared plus 2x delta x plus delta x squared. In denominator, distribute negative 3 to each term of x plus delta x. And we have 1 minus 3x minus 3 delta x. Then, substitute each to the definition of derivative. Limit of g of x plus delta x, which is x squared plus 2x delta x plus delta x squared over 1 minus 3x minus 3 delta x minus g of x, which is x squared over 1 minus 3x all over delta x as delta x approaches 0. Find the LCD. The LCD is the product of 1 minus 3x minus 3 delta x and 1 minus 3x. Multiply LCD to numerator and denominator. Get the product of the first term of the numerator and the LCD. The factor of 1 minus 3x minus 3 delta x is eliminated and multiply the remaining factor, which is 1 minus 3x, to the numerator of the first term. Next, multiply LCD to the second term of the numerator. The factor of 1 minus 3x is eliminated and multiply the remaining factor, which is 1 minus 3x minus 3 delta x, to the numerator of the second term, over the product of the denominator, which is delta x and entire LCD. Expand numerator. The product of 1 minus 3x and x squared plus 2 delta x plus delta x squared is x squared plus 2x delta x plus delta x squared minus 3x cubed minus 6x squared delta x minus 3x delta x squared minus the product of 1 minus 3x minus 3 delta x and x squared is equal to x squared minus 3x cubed minus 3x squared delta x over the whole denominator. Remove grouping symbols in numerator. Limit of x squared plus 2x delta x plus delta x squared minus 3x cubed minus 6x squared delta x minus 3x delta x squared minus x squared plus 3x cubed plus 3x squared delta x over the whole denominator. Combine similar terms. X squared minus x squared is 0. Negative 3x cubed plus 3x cubed is 0. And negative 6x squared delta x plus 3x squared delta x is negative 3x squared delta x. Limit of the remaining terms in numerator, which is 2x delta x plus delta x squared minus 3x squared delta x minus 3x delta x squared over the whole denominator. Factor out delta x in numerator. We have limit of delta x multiply to the 2x plus delta x minus 3x squared minus 3x delta x over the whole denominator. Eliminate delta x. We have limit of 2x plus delta x minus 3x squared minus 3x delta x over the product of 1 minus 3x minus 3 delta x and 1 minus 3x. Apply limit property. Limit of the numerator and the limit of denominator. Apply limit properties to numerator and denominator. We have limit of 2x as delta x approaches 0 plus limit of delta x as delta x approaches 0 minus limit of 3x squared as delta x approaches 0 minus limit of 3x delta x as delta x approaches 0 over limit of 1 minus 3x minus 3 delta x as delta x approaches 0 multiply to the limit of 1 minus 3x as delta x approaches 0. Continue to apply limit properties in the denominator. Rewrite the numerator over the limit of 1 as delta x approaches 0 minus limit of 3x as delta x approaches 0 minus limit of 3 delta x as delta x approaches 0 multiply to the limit of 1 as delta x approaches 0 minus limit of 3x as delta x approaches 0. Get the limit of each term. We have it is equal to 2x plus 0 minus 3x squared minus 3x times 0 over the product of 1 minus 3x minus 3 times 0 and 1 minus 3x. Simplify. We have 2x minus 3x squared over the product of the difference of 1 and 3x and 1 and 3x. Rewrite denominator. Then the derivative of the function is 2x minus 3x squared over the square of the difference of 1 and 3x. By using this derivative, it allows us to find the slope of the function at any point on it. Find the slope of the function at 1, negative 1 half. I encourage you to pause this video and give it a try. In graph, this is the point where are asked to find the slope of this function. To continue, use the derivative to find the slope of the function at a given point. Substitute x coordinate to the derivative. We have g prime of 1 is equal to 2 times 1 minus 3 times the square of 1 over the square of 1 minus 3 times 1. Simplify. 2 minus 3 over the square of negative 2. Continue. It is equal to negative 1 over 4. The slope of the function at 1, negative 1 is negative 1/4. Next, find the equation of the tangent line on the function at the same point. Substitute values in point slope form. Y minus y coordinate, which is negative 1 half, is equal to the slope, which is negative 1/4, multiply to x minus x coordinate, which is 1. Simplify. Y plus 1 half is equal to Distribute negative 1/4 to each term of x minus 1 and is equal to negative 1/4 x plus 1/4 plus 1/4. Subtract 1/2 to both sides of the equation. It is simplified to y is equal to negative 1/4 plus 1/4 minus 1/2. Combine fraction, it is equal to y is equal to negative 1/4 minus 1/4. The equation of the tangent line on the curve at exactly on the same point is y is equal to negative 1/4 minus 1/4. There you have it. How to find the derivative of a rational function. Next videos discuss how to find the derivative of other functions. If you learn on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!